Hello friends, have you ever heard about the atomic bomb, which was dropped on Hiroshima in Japan and the whole city was destroyed? This much power is generated from the nucleus of the atom and is not only used in bombs, but in making electricity also. The scientist who discovered ways to use this power was Dr. Homi Bhabha. Today we'll learn more about his life and the interesting power of the nucleus of an atom. In this video, Homi Bhabha was born on October 30th, 1909 and died on January 24th, 1966. He was an Indian nuclear physicist who was widely known as the father of the Indian nuclear program. Founding director and professor of physics at the Tata Institute of Fundamental Research, as well as the founding director of the Atomic Energy Establishment, which was named as Bhabha Atomic Research Center in his honor. He was awarded the Adams Prize and Padma Bhushan and nominated for the Nobel Prize for Physics in 1951 and 1953 to 1956. Homi Bhabha was born into a prominent wealthy Parsi family, comprising Jahangir Hormushji Bhabha, a well-known lawyer, and Meherbai Framji Pandey, granddaughter of Sir Dinshaw Manekshi Petit. He received his early studies at Mumbai's Cathedral and John Connon School. Bhabha showed great interest in science. As a child, he spent hours playing with Meccano sets and was fond of building his own models rather than following the booklets that accompanied the sets. By 15, he had studied general relativity. He passed his senior Cambridge examination with honors at the age of 15, but he was too young to join any college abroad. So, he enrolled in Elphinstone College. He then attended the Royal Institute of Science in 1927, where he witnessed a public lecture by Arthur Compton, who won the Nobel Prize in Physics the next year for his 1923 discovery of the Compton effect. You can find about the Compton effect in books and read about that. Bhabha later said that he first heard of cosmic rays, the subject of his future research, at this lecture. 1 year later, he joined Gonville and Caius College of Cambridge University. This was due to the insistence of his father and his uncle Dorabji, who planned for Bhabha to obtain a degree in mechanical engineering from Cambridge and then return to India, where he would join the Tata Steel Mills in Jamshedpur as a metallurgist. Bhabha worked at the Cavendish Laboratory while working towards his PhD degree in theoretical physics supervised under Ralph Fowler. At the time, the laboratory was the center of several breakthroughs in experimental physics. James Chadwick had discovered the neutron, John Cockcroft and Ernest Walton had transmuted lithium, Francis Aston had discovered chemical isotopes, and Patrick Blackett and Giuseppe Occhialini had used cloud chambers to demonstrate the production of electron pairs in showers by gamma radiation. Bhabha was later selected for the Isaac Newton Scholarship, which he held for the next 3 years and used to fund his time working with Enrico Fermi at the Institute of Physics in Rome. The same year, Bhabha published his first paper on the role of electron showers in absorbing gamma radiation. The discovery of the positron in 1932 and the formulation of Dirac's whole theory to explain its properties had catalyzed the creation of the field of high-energy physics. Bhabha chose to make this field the focus of his career, publishing over 50 papers on the topic during his lifetime. He played a key role in the early development of quantum electrodynamics. Bhabha received his doctorate in nuclear physics in 1935 for his thesis titled On Cosmic Radiation and the Creation and Annihilation of Positrons and Electrons. In 1935, Bhabha published a paper in the Proceedings of the Royal Society in which he first calculated the cross-section of electron-positron scattering. Electron-positron scattering was later named Bhabha scattering. Bhabha later concluded that observations of the properties of the meson can lead to the straightforward experimental verification of the time dilation phenomenon predicted by Albert Einstein's theory of relativity. Bhabha had returned to India for his annual vacation before the start of World War II in September 1939. Due to the war, he remained in India, where he accepted the post of Reader in Physics at the Indian Institute of Science in Bengaluru, headed by Nobel laureate C.V. Raman. While introducing him at the 1941 annual meeting of the Indian Academy of Sciences, see 5th, Raman described the 32-year-old Bhabha as the modern equivalent of Leonardo da Vinci. During his time in Bengaluru, Baba met Vikram and Mrinalini Sarabhai as part of a group interested in Indian culture and developed an appreciation for Indian architectural and artistic heritage on his tours around the country. In a letter to the astrophysicist Subramanian Chandrasekhar, Baba described that his ambition was to bring together as many outstanding scientists as possible to build up in time an intellectual atmosphere approaching what we knew in places like Cambridge and Paris. The trustees of Sir Dorabji Tata Trust decided to accept Baba's proposal and financial responsibility for starting the institute in April 1944. In June 1945, with a grant from the trust, he established the Tata Institute of Fundamental Research. TIFR began functioning in the Cosmic Ray Unit of the Indian Institute of Science, Bangalore, by October of that year, and later on it moved to Bombay. Some of TIFR's research groups focused on nuclear chemistry and metallurgy. These were later moved to Trombay to provide the basis for a plan to integrate nuclear energy into the national power grid. By 1954, the institute contained an in-house electronics production unit. Under Baba's leadership, the institute established a research group under Bernard Peters' supervision to conduct research on cosmic rays and later geophysics. On April 26, 1948, Baba wrote to Prime Minister Jawaharlal Nehru that the development of atomic energy should be entrusted to a very small and high-powered body, composed of, say, 3 people with executive power and answerable directly to the Prime Minister without any intervening link. When Baba realized that technology development for the atomic energy program could no longer be carried out within TIFR, he proposed to the government to build a new laboratory entirely devoted to this purpose. For this purpose, 1,200 acres of land was acquired at Trombay from the Bombay government. Thus, the Atomic Energy Establishment, Trombay, AEET, started functioning in 1954. Baba is credited with formulating a strategy of focusing on extracting power from the country's vast thorium reserves rather than its meager uranium reserves. In 1952, Indian Rare Earths Limited, a government-owned company, was established to extract rare earth and thorium from Kerala's monazite sands, with Baba serving as its director. In July 1958, Baba decided to build a plutonium reprocessing plant in Trombay. Construction of the Phoenix plant, based on the Purex technique for extracting plutonium from spent fuel, began in 1961 and was completed in mid-1964. Paired with CIRUS, Phoenix produced India's first weapons-grade plutonium in 1964. In the 1950s, Baba represented India in International Atomic Energy Agency conferences and served as president of the United Nations Conference on the Peaceful Uses of Atomic Energy in Geneva, Switzerland in 1955. After the Chinese nuclear test, on October 16, 1964, Baba began to publicly call for building nuclear explosives. On the other hand, Prime Minister Lal Bahadur Shastri, Nehru's successor, sought security guarantees from the existing nuclear powers while declaring at the Cairo Conference of Non-Aligned Nations that India's nuclear establishment was under firm orders not to make a single experiment, not to perfect a single device, which is not needed for peaceful uses of atomic energy. On a visit to London, on October 4, 1964, anticipating the Chinese test, Baba said that India could conduct a nuclear test within a year and a half of a decision to do so, but that he did not think such a decision will be taken. Baba was an avid painter, decorating his house with abstracts. He painted during the 1930s in England. He gained international prominence after deriving a correct expression for the probability of scattering positrons by electrons, a process now known as Baba scattering. His major contributions included work on Compton scattering, R process, and the advancement of nuclear physics. He was nominated for the Nobel Prize for Physics in 1951 and 1953-1956. He was awarded Padma Bhushan, India's third highest civilian honor, in 1954. Baba received several honorary doctoral degrees in science throughout his career: Patna, Lucknow, Banaras, Agra, Allahabad, Cambridge, and Padova, 1961. Baba died when Air India Flight 101 crashed near Mont Blanc on 24 January 1966. A misunderstanding between Geneva Airport and the pilot about the aircraft position near the mountain is the official reason of the crash. Bhabha is considered the father of the Indian nuclear program and one of the most prominent scientists in the country's history. After his death, the atomic energy establishment at Mumbai was renamed the Bhabha Atomic Research Center in his honor. Bhabha encouraged research in electronics, space science, microbiology, and radio astronomy. The radio telescope in Udi, India, which is one of the world's largest steerable telescopes, was built by Bhabha's efforts in 1970. That's the amazing story of nuclear scientist Dr. Homi J. Bhabha, the revolutionary scientist who started nuclear research in India and supported space science projects to find the secrets of nuclear power and inspired young minds around the world. So, if you could ask Homi Bhabha one question, what would it be? The secrets of nuclear power, or how small atoms can generate so much energy? Let us know in the comments below. And if you learned something from the video, then please like, share, and subscribe for more such videos on the lives of great personalities of the world.